that. So when you do modeling, you need data, right? So let's just say I have some data. Well, let's make it larger. 0, 100, 1, 200. Let's just say this is my data, okay? All right, so let's say this, you'll be working with your own data set. You'll figure that out. But if you have large numbers like this, you're not going to see them in your window. So that's one issue. So you're going to have to just build your own window, right? In other words, just zoom out. So I know that my data is mostly positive. So maybe I just start at -1. I'm going up to 5, so maybe I want to see 7. The X part's easy. Now look at your Y part. You're going from 100 to 750. So maybe I want to see 1,000, right? Just a bit above my highest Y value. And then you can see your points, right? And you can also mess with the step if you want them to go up. And Desmos does a pretty good job with the step. And when the step it's just like the distance to all your tick marks. So it looks like they're going 50, 50, 50, 50, which is pretty good. Okay, so you can mess with this by clicking on this little wrench for your settings. And here's my graph. That looks kind of like a linear graph. So that might be the first guess. But if I change this to 900, it looks, it's got a little more curve to it. But the next thing you'll do is model it, okay? And here's how you model. Your table values are called Y1, the outputs, and your inputs are called X1. So you're going to need to tell Desmos that. So I'm going to go Y1 equals, oops, sorry, not equals, Y1, it'll automatically do the subscript for you. And then we use the tilde, all right? That's on the left uppermost part of your keyboard. And that's used a lot for approximately in mathematics. And this is going to be our approximate function that represents this data, right? It won't be perfect because we're just modeling it. Okay, and now you're going to tell Desmos what model you want. So you got lines, you got power functions or quadratic functions, you got exponential functions. So let's start with the exponential. I'm going to try and model this data. Well, let's do the line first. So mx plus b, right? You know that x is your variable, m and b are your parameters. In Desmos, you always start with a for your parameter. That is a constant. And then the x isn't x, it's x1, right? Because you want it to use this data. And then the next parameter, constant value, would be b, a, b, c. Okay, so there's a line. That's linear regression. That's going to fit our data as best as possible to the line. All right, well, let's say we don't like that one. Let's do a quadratic. Okay, so quadratic, you have a couple options. Basic quadratic would be just ax squared, right? X squared is your basic quadratic, but we need a parameter, which we'll call x, and then x1 squared, okay? I just went caret 2 and it squared it for me. So now it's trying to, why is that guy there? 0, oh yeah, that's right. So it's trying to fit as best it can to the data. So it's not very good. So we might know we can push this guy up, right? If I see that this first point's 100, I might be able to say, well, what if I just added a b, right? And I noticed I didn't put 100 in there. I put b. I let Desmos do the work because it's not going to go through what we think is the y-intercept. It's going to fit best to all the points. Okay, and that's not a bad model right there. So that was my second parameter. I thought to do that. You could also make it a trinomial, bx1. I don't know why that's linear. There it is. So that's even better, right? So I went from ax squared, and then I said, well, let's just add a b, and then I made it the most accurate I could, bx plus c. Okay. So you might not have to do that. I'm just trying to show you how this works. It's a really useful tool. So let's talk about exponential. So if I asked you to do exponential, you would say e to the bx, right? But if there's another parameter in there, there would be a constant, and then an e, and then to the power of bx1. All right, so that is my my y-intercept, my starting point that Desmos finds for you based on this data. Does its best to get to 0, 100. B is a parameter, like your coefficient of x, and x1 is your input. Okay, and I'm going to click on log mode. Typically, this is a little bit more accurate. Don't worry about really what that means, how the computer's doing it. You can actually look at it. It does explain it. But we just want the best data possible. Or the best model possible, rather, based on this data. So what's your model then? Your model is y equals a, and the A's down here. So it went 116. That's pretty close to our 100. And then it has your rate B as 0.43. Okay. So that's with base E. Right? Remember, E is not a parameter. E is a constant value. These are what Desmos does to fit your data. They mess with A and B. Okay. So the other option would be a base A, which is something I'm going to ask you to do. Okay. So the basics would be A to the X, right? But we need a constant and then times the exponential piece. So how these work is that the B is going to kind of take care of our rate, right? So when we go to the power of X, we don't need a parameter for coefficient of X, right? Because that's kind of built within this piece. Right? And actually one of my videos kind of explains how you can get from B to the X, or just any base to the X, to E to some power X times some coefficient. Okay, and I'll stick with log mode, and then I have a different exponential function that's really the same exponential function, but with different parameters. Okay, and then I think I asked you to do one more, which is a square root function. And I think that's right. It just doesn't like. Oh, we need a parameter maybe. There we go. Yeah. So so that's the whole. It's all about that parameter, right? That parameter is gonna adjust so it fits the data as well as possible, and that's not a very good root function, but it's trying, right? And I think those are the four functions I'm going to ask you to model. There's going to be a basic quadratic, a root function, and then two different exponential functions.